Your charger is plugged into the wall right now. There is no voltage coming out of it. None. Zero. It isn't broken and it isn't asleep. It's refusing, and it will keep refusing until something on the other end says the right thing. Now put a second charger on the other end of that cable, two of them, facing each other, both plugged in, both sitting at zero, each waiting for the other to speak. It fits perfectly. Nothing stopped you. Every rule you trusted with your hands was a shape. Now it guarantees nothing, and that guarantee moved somewhere you can't see. So what was the shape doing? Look at the connector that came before. Two ends, deliberately different. One plug went to the computer. A different plug went to the device. That wasn't for your convenience. It was a rule made out of plastic. The computer end was the end allowed to supply power. The device end wasn't, and the computer's plug does not fit the device's socket. It will not physically go. So the wrong connection was never detected and never rejected. It could never be attempted. Every guarantee lived in the geometry. Which side is in charge? Which side supplies power? Which way the data flows? None of it was ever decided. All of it was already true the moment the plug went in. Then both ends became the same shape. Now make both ends identical. The socket is mirrored. Two matching sets of contacts, top and bottom, so the plug goes in either way up. That's the whole point. That's the part you like. Look at what it costs. The two chargers at the start were not a special case. Nothing stops you joining any two things that should never have met, and you cannot see the difference, not with your eyes. The order of the signals inside even flips depending on which way the socket was mounted to the board. The shape stopped being a promise. Something else has to make one. Inside the socket, two contacts are set aside. They carry no data. They exist to answer one question. What is on the other end? Here's the trick. The cable connects only one of them. So the port watches both. An answer on the first means the plug is one way up. On the second, it's the other. Attachment and orientation from a single observation. And what it's watching for is a resistor. The device side pulls that line down to ground through a resistor. 5.1 kiloohms. That is the entire declaration. It means I am the side that receives. The supply side pulls the same line up instead. Its value isn't fixed. The value is the message. It says I am the source and how much current it has. No processor, no software. Two terminations and the voltage between them. And a port that hasn't decided yet just alternates. Offering to receive, offering to supply until something answers. But knowing who's in charge is not the same as knowing what to give. Now watch the power wire. Before anything is attached, it's dead. 0 volts. Not idle, off. Attachment brings it to a low, safe 5 volts. Enough to talk. Not enough to harm anything. Then the two sides have a conversation over the same configuration line that just settled the roles. The supply advertises what it can offer. The device asks for one of those. The supply accepts. Only then does the wire move to the agreed level. 3 things resolve together: what the supply can give, what the device needs, what the cable can carry, and none of it is permanent. The side supplying power can become the side taking it. Data can reverse the same way. Either can flip without unplugging anything. So a port isn't a charging port or a data port. Those aren't properties. They're the current state of an agreement, which leaves one participant we haven't heard from. The cable is not passive copper, not anymore. A cable with electronics inside presents its own termination, a third kind on a line of its own. It means I contain electronics and I need power for them. Notice the order. The cable isn't powered and then asked. It has to declare itself first, and it's powered only after. Then the supply asks what the cable can survive, and the chip in the cable answers. That answer is 2 bits wide. 2. That's the whole of what a cable says about the current it can carry. Only the most basic cable is allowed to stay silent. And here's the part worth sitting with. A silent cable doesn't cause a guess. The supply is simply never permitted above the baseline because permission is something the cable grants and silence grants nothing. The system doesn't trust the cable, it refuses to act without it. Everything so far decided what flows through the wires, Nothing has changed what the wires are. Inside the cable are 4 high-speed pairs. In ordinary use, they carry USB data. They don't have to. The same configuration line that assigned the roles and negotiated the power can hand those physical wires to a protocol that has nothing to do with USB. Give all 4 pairs to video, and you get the most a display can take, with no high-speed USB left at all. Or split them. 2 pairs carrying picture, 2 still carrying data. And there are 2 more pins in there that do nothing whatsoever in normal operation. They aren't spare capacity, they're there to be borrowed. The display's own side channel runs on them. Same hole, same cable, same wires. Doing an entirely different job. So, the old connector enforced its rules with plastic. You could not plug it in wrong. USB-C gave that up. Every end identical, every guarantee gone, and rebuilt all of them as a conversation that runs before anything is allowed to work. Who's in charge? How much power? What the cable can take? What the wires will carry? None of it is in the shape. Everything the shape used to guarantee still happens. Agreed from scratch, in the dark, every single time. That's why USB-C is just the shape of the whole.